3, 2, 1. Germans. This question is located in your exam papers again, January 2026. Page X in your exam papers 382 for ye, January 2026. So, Germans here owns an ice cream van, 7 flavours of ice cream, 4 different toppings, 2 containers. I mean, you can't get any more clearer than the fundamental principle of counting here. 7 4 is 28. You can have 56 different 56 choices of whatever you want to pick there in that question. So 56 choices going on there. What's going on there? That's something called the fundamental principle of counting. You could be asked this in your exam. You could be asked, state the fundamental principle of counting in your exam. So, this fundamental principle of counting here, if one event has M outcomes and a second event has N outcomes, and a third event has O outcomes and a fourth event has K outcomes, then the total number of outcomes would be, in this case, M by N, or M by N by O, or M by N by O, or whatever is going on there. So you can see here, I'll just give you a simple example. You have 3 shirts to pick from, you've got 2 pairs of pants. How many outcomes in total? So I could have a blue jeans, a blue khakis, I could have a red jeans, red khakis, green jeans, green khakis. Quick way to do that is 3 by 2. Is 6 there, unique outfits. It's great for restaurants where you might have 3 starters, 5 main courses and 4 desserts. 3 by 5 is 15, 15 by 4 is 60 different possible starter, main and dessert choices you could have there. So that's the answer to the first one anyway. 7, fundamental principle of counting. That's M events. I can get this working back in here. So M events there, N events here, and let's say O events here. So M by N by O, and answer is done. Moving on. Next one here. German wants to maximize the number of choices available to him. The only thing you have to do here is go and prove it. Extra flavour. And the other one there is extra topping. So you have to actually do this. So originally we had 7 and we had 4 and we had 2. I'm just spacing them out because I didn't want to go multiplying them. I think it was 7 different types of ice cream, wasn't it? So ice cream. What was the 4 for? Toppings. And what was the what was this last one? The kind of containers. Containers is something I think it was called. So basically, right, what's going to happen here? Extra flavour. Which one was the flavour? Sorry. Oh, that was ice cream flavour. That was that one up there. Isn't it? Yeah. So, that's the one we need to change first of all. Give an extra flavour. 7 plus 1 is 8. You still have 4. You still have 2. You now get 8 plus 4 is 32 by 2. 64 choices. Right, not too bad. It's increased it as expected. But what about the toppings here? So, the flavour stays the same. The topping will go up by 1 to 5. So, I double box that. 4 plus 1 is now 5, and the last one there, the container, stays the same, and that goes 7 there. So multiply them. 7 by 5 is 35 by 2, 70 choices. So I think you can clearly see there that one beats this one. So I think I've proved enough there that the extra topping is the one to maximise the amount that customers could have. Next question. Venn diagram here. Right, easy part first of all. Vanilla flavour was, first thing I suppose I noticed here, you're asked all this stuff. Vanilla 42, cone 37. Right, 45 people didn't get any ice cream at all. No matter what, vanilla, cone, nothing. They got nothing there. So that's going to be 100 minus 45, leaving you with 55 people in this region here. So 55 people done something in here. Right? Now we have an overlap here. We know that 42 of them got the vanilla flavour. We know 37 of them got a cone. So we've got to allow for our 42 plus 37 is 79 people total. But that's more than the 55. So all we do to allow for double counting is we just take away the 55. We get 24. That tells us what goes in our intersection. 24. Right? Then we know 42 people in total got vanilla. So 24 from 42 is 18. You can do your calculations there if you want. 42 minus 24 is 18. We know that 37 people in total got cones. We know that 24 of them also got the vanilla in their cones, so that's 13 people left. 37 minus 24 is 13. Finished. Okay, next question. Right, I had already set up here. Customers picked at random from the 100 customers. Find the probability that the customer bought a cone with the flavour other than vanilla. That section there, other than vanilla, 13 out of 100 is the probability. Simples, easy peasy. On to part C here. Right, so another expected value question here. So we want to work out expected ice cream sales. So E for expected value here, or E of X if you want, for the expected value of the ice cream sales is going to be equal to our sum of each individual calculation, where we get our event multiplied by the probability of that event, which in this case is the probability of the weather condition. Now this should make sense here, lads. We're getting, we're going to do the same thing again. We're going to get 30% multiplied by of 150. We're going to get 45% of 200. We're going to get 25% of 450. Once we get all them, we're going to sum them, our answers together, and we're going to find out. So let's do that. So ice cream sales when the weather is wet. When the weather is wet, you know, Jesus, you're not going to do typical ice cream sales, but with the weather condition being wet, you're going to get 30% of sales. So 150 by 30%. Add. So on a dry and cold day, look, you're selling a few more, but 45% chance of getting that 200 euro on a dry and cold day. So that's 200 by 0.45. And the last one there, so right, nice day, dry and warm. You have a good chance to sell, you have a 25% chance of selling 450 euro. It's worth of ice creams. Or on average, I should say, you have kind of a 25% chance. So you work out all that stuff there, and I think you end up with, I don't know. What's Gary?
247, 57.
Yeah, and that is the expected sales that Jeremy would expect to make on average. Remember, this is kind of theoretical here, or working out the average that we would expect. Like obviously on the day he could sell another 500 euros worth of ice creams there, you know, we don't know. We're just predicting it on kind of previous information and that, okay? So this is previous information and we're working out the expected value, or this is what he predicts will happen. So that's that question. Yeah, done. Right. That'll do.